I guess I wanted to start off here with the 10,000-foot question that we're asking here. Is we want to ask, there's a lot of talk about soil health. Lots of people talking about different components of it. And, I wanted to kind of just take a step back and ask, does a healthier soil actually require less fertilizer, right? This is an often touted claim of it. And so we wanted to maybe try and test this. So maybe to start off, making sure that we're all on the same page here, right? So soil health, it's a thing that we've all been talking about here. I've seen a couple talks on it the last couple days here. But soil health kind of sits at this intersection of soil physical health, soil chemical health, and soil biological health, right? It's not any one of those, it's kind of all three of them. So that's a good thought, right? But the new part is kind of integrating that soil biological component. So, this is a recent study they looked and they said, okay, how often are these different indicators actually used, right? And as you can see here, this is around the world, and up here in the green, we have the soil biological indicators. And they're not used very frequently. This dotted line here is at about 30%. So in studies kind of around the world, when people are looking at soil health, when they say they're studying soil health, biological indicators are only being included in that about 30% of the time, right? And these are even the most common ones, right? So the ones they have here are earthworm counts, nitrogen mineralization, there is microbial biomass, and soil respiration. So those are the most common ones, and there are a bunch of other ones as well. So, that doesn't look very good. This used to have data points on it, but anyways, this is from a recent meta-analysis. The one thing we do know is that soil organic matter is good for yield. And now if we can all use our imaginations here, there's a bunch of data points, and it kind of levels off around about 2%, right? So when you have above 2% soil organic carbon, which is about 4% organic matter, yields kind of start to level off. The effect of organic matter on yield starts to level off, right? So, but most of us here in Ohio, we are kind of down in this range here. To start kind of integrating this into making fertility recommendations and blending the world of soil health and soil fertility and unifying them here, that's a relatively recent kind of endeavor. So there is some work being done on this right now. So this is the flush of CO2 following rewetting, which is the Solvita test, or it's the respiration component of a Haney test. This is probably a very common, probably the most common soil health, biological soil health indicator. And as you can see here, it had a pretty good relationship with dry matter production. This was in forage systems. Now, unfortunately, this was not here in Ohio. It wasn't even in the Midwest. This was done down in North Carolina. So, we don't have those kind of calibrations or any sort of information here yet. But we were trying to maybe address this in a large-scale systematic way. So in our lab here at Ohio State, we have three kind of predominant soil biological health indicators that we use. So again, respiration, which is the most popular one, that is Solvita or the Haney test, or one component of the Haney test, I should say. Then we use this, what we call POXC, or active carbon, and that is kind of like how much carbon is there, right? So respiration is maybe a measurement of how hard your microbes are working, right? Just like when I go for a run or something like that, I breathe really heavy. I'm giving off lots of CO2. Microbes are doing the same thing. When they're doing more work, they're going to be giving off a lot of CO2, right? So, but what are they kind of feeding on here? What are they metabolizing? So we consider this active carbon pool, the POXC, that's their carbon source. So that's what they're chewing on. And then this soil protein, that is what we think of as their nitrogen source, right? So we want to say, okay, we bring all of these things together, and those are going to be describing your soil biological health. So, but then we say, how do those contribute to a decrease or an increase in your nitrogen fertilization rates? So our big picture kind of questions here are, we have this conceptual framework, right? We got that nice little diagram here, how they all kind of link together. So, but we want to say, are those actually describing the same kind of underlying process, these three indicators, right? Are those actually telling us information specifically about the nitrogen supply from the soil? What he was talking about earlier with the nitrogen mineralization, right? Then the second kind of big question is, do those measurements predict crop responsiveness to nitrogen fertilization? So can you go out, take a soil sample, send it in, and do these soil health indicators give you any information about whether you're going to be responsive to N? Right? Do you need that 0 N rate, or are you going up to that 200 pounds? So to maybe address this in a huge scale way, we brought together a bunch of people from different land grants around the Corn Belt here. And so we've got a bunch of different sites around the Midwest. And we had a couple different criteria for, including these in our study. So first off, they're all rain-fed, and we were measuring corn yields, right? We need to have a minimum of 4 nitrogen rates, including a check, a 0 or a starter only. And then we also had all kinds of different traditional soil health building practices, right? We had cover crops of all different types. We had manure applications. We had different rotation lengths. And then we also had variations in tillage intensity. So it kind of ran the gamut, right? We have a broad range of soil health encapsulated in this. And again, this is spread across 6 states, and we had 31 different sites, right? All of those are replicated within that site. So let's just go for these straight relationships here. So first off, this is, for those, I think everyone can see, but this is respiration here, right? This is microbial activity, and this is relative yield expressed as a % of your AONR yield, right? So as you can see here, there is this general upward trend, but if you look at this R squared value here of 0.03, I wouldn't go, betting too much on that. This data again is pretty noisy, right? But maybe there are other indicators. So here, this is the POXC, or the active carbon, right? This is the carbon food source. So I said, okay, that one, it's again a little bit better, but still 0.07. So that's not a very good, strong relationship here yet, right? So soil protein, that's the nitrogen food source. That one's going to be good, right? Well, all by itself, it's not doing so good. It's better than the other ones so far, but it's still not giving us any information that you can really put in the bank here. So, we were thinking like, okay, what's the problem here? What's going on? And everyone, we always talk about field-to-field variability, right? Everyone's field is unique. And that really hinders us from making like good recommendations, right? So, in order to make sure that we're getting at this right, we wanted to, okay, maybe we need to be better at stats. Now, before everyone's eyes gloss over, I know mine generally do when it comes to statistics, but I want to take you from, I'm this guy, right? I want you to all kind of join me in this excitement, maybe not excitement, but at least don't just tune me out here. So just as like a quick little thing, so usually when we're looking at these relationships, right, we have some sort of response here, this Y, and we're getting some signal from the thing we measure, whether that's soil test phosphorus, whether that's fertilization rate, or in this case, a soil health measurement, right? So what we want to say is, okay, we have that signal, what we apply, but then there's all kinds of error. There's just environmental error, right? Whether it was a rainy year, or maybe there's just measurement error. Maybe when you took your soil sample, it was a hot spot, something like that. We've got some source of error, right? So in our measurements we took here, you can tell there's kind of a lot of error, right? But what we wanted to do is we wanted to say, okay, let's take into account the error within a field, right? So that way we can piece out what are our measurements actually telling us. We can reduce this kind of error here. So that way we actually can extrapolate and say, your field is going to be the same as your field. What's that signal across fields? And give you a really good kind of prescription here. right? So again, this right here, this signal from our soil health measurements is what we're really interested in. So just maybe as an example, using the data I just showed you, right? So here we go, here are our different indicators. This is the way that most people do it, and this is the way that we did it. So there's kind of two things that I want to bring your attention to here. So first off, I'll give you the bad news, right? So the bad news is that when we account for field level variability, the variation between fields, that signal that we're interested in shrinks a little bit, right? So if we see here, it goes from 0.07 R squared to 0.03 is there, right? So that's only 0.03 or 3% of it is actually being captured across fields. And again, here we can see it goes from 0.03 to 0.0, pretty much nothing. And so all of these go down, right? So, but of course there's the bad news, and then we get the good news as well. The good news is that overall we're getting a more accurate prediction, right? So we can see here that we go from 0.07 to 0.32. So that's 30% of our variation was coming from just our field-to-field variability, right? So this is us trying to move forward and having some better confidence in these soil health measurements, right? So here's the problem, one of the problems with soil health, a couple of them, as I see it. So soil health is not something we can go out and directly measure, right? Unlike people, we can go and I can say, you know, are you healthy? How you feeling? Talk to me. Soil doesn't give us that information. So it's not something that we can go out and measure in a single measurement, unfortunately. So that is comprised of multiple variables, right? And then the last problem is, soil health is a variety of outcomes. And so it changes for everyone. Whether you want, if you want infiltration, better structure, you're going to have a completely different set of soil health indicators, right? So for this, we are looking at as our desired outcome is crop nitrogen supply, right? So that makes soil health really difficult to deal with from a statistical perspective, but also from just a practical perspective. So to get around this, we're using this, it's some fancy stats again, but what it is it's basically saying, okay, we measure all these things and there's something kind of underlying it, right? There's this thing that's giving us this signal that we're interested in. This was originally developed for measuring intelligence, right? Intelligence isn't your reading score, it's not your math test score or what have you. It's kind of all of these things combined. So similar to soil health. Soil health isn't just your infiltration, it's not just your carbon or your respiration, it's kind of all of those things together, right? So we chose our kind of 4 measurements of interest, our 3 that we love here, and then also organic matter. And this is the organic matter that you would get from your traditional agronomic test, right? And so we said, how do these things combine, to describe soil health here? So what we found is there's kind of 2 different signals, 2 different directions that this is pulling us, right? So the first one here is this POXC or active carbon. So again, that's the carbon food source, and this respiration or mineralizable carbon, how hard the microbes are working. Then over here, we've got our total organic matter content and our soil protein content, right? So these are 2 different signals that we actually used to think were the same one coming from these variables that we were measuring. We used to just throw them all together, but this is saying maybe there's actually 2 different signals simultaneously. So, right, but that still doesn't get us to, okay, how does that help us with nitrogen fertilization, right? So we said, okay, theoretically, what will this relationship look like? If it happens how we expect it, what would it look like, right? So this is your residual nitrogen content, right? So that's your pre-plant nitrate content. And so what we would think is when you don't have very much pre-plant nitrogen, you're not going to have as good a relative yield, right? You're going to be more responsive to nitrogen fertilization. But as you get more and more inorganic N here, you're going to be less and less responsive. So then when we layer soil health on top of that, you would think actually a healthy soil, so that's that blue line there, would be less responsive, right? An unhealthy soil is going to be more responsive. That slope is going to be much steeper as you increase your fertilization. So then we say, okay, we have this soil health thing, and it's also related to inorganic or pre-plant nitrate, right? And then how does that relate to our relative yield? When we combine those things, what information do we get about responsiveness to nitrogen fertilization? So here it is when we throw it all together, and there's a couple different numbers up there, but I'm going to draw your attention to the important ones, right? So first off, the important thing is that these two different sets, these two different soil health signals that we're getting, if you will, they both don't relate to relative yield. The only one that does is this soil health 1, so that's the mineralizable carbon and the active carbon here, right? So those are going to be more related to relative yield than this organic matter and soil protein content. But this is kind of like the traditional relationship that we think of, right? Right here is if you have higher inorganic N, you're going to have a higher relative yield. So we did see that relationship. It's still showing up here, right? Still there. And again, this is kind of the new one, the one of interest for us. And so this is a relationship here is the value is 0.16. So these are all standardized values here, so that way we can compare across them, just for reference. Right? So, but then the problem is, we have this effect on relative yield, but it's not just going here, it's also going to be going, it's also giving this effect here, right? So we want to be able to tease those apart, and what is the magnitude of that signal is what we're really interested in. What is the magnitude of the soil health signal on this relative yield here? So what we have is we have the direct effect of this on it, on relative yield, right? So that was 0.16, just, anyways, it's a standardized thing. And then the effect that it's exerting through the inorganic N content is actually just about the same size, but in the opposite direction. And so what that net effect is there is they actually kind of are canceling each other out. So what does that mean? That means that soil health, as we are measuring with these variables, maybe isn't giving us that much information about responsiveness to nitrogen fertilization, right? We don't have anything that we can really add to Harold's nitrogen trials from earlier yet, right? Yes. Yes. That was based on soil tests from, we went out pre-plant, took a soil sample, measured some soil health, and then pre-plant nitrate. Yes, whatever, I mean, I don't think much would have mineralized over the winter. This is pre-plant, again, in the spring, going into corn. Got it. Okay. So then, there's really 3 take-home messages here that I want to kind of give you here right at the end of the conference. So 1, field-to-field variability continues to be the thorn in our side, right? It is continuing to really throw us for a loop here. So we need to be careful, as this is for us as researchers and anyone who is kind of building their own relationships here, you know, extrapolations. We need to be really careful about incorporating that field-to-field variability responsibly. Remember, before we were overestimating the size of the effect, the size of our signal. 2, we shouldn't assume that these soil health metrics describe the same underlying processes, right? We had 2 different processes kind of in opposition to one another. And that's going to be actually a pretty critical kind of thing to remember as we're trying to connect soil health to some sort of fertility outcome. And 3, these soil health indicators, at least the ones that we included here, aren't giving us much valuable information in terms of N responsiveness right now, right? And what we do see so far is a relatively small effect. Now that's not to say, again, that every field is going to be like that. There are potential things, when this is kind of what we're looking at later. We can do calibrations, right, for a more regional or a more localized thing. Remember, our sample size was, or our sample region was fairly large. But of course, there are always the lingering questions. So the 2 things that we have that are still burning questions in my mind that we're going to use this data set to address is we're going to say, is that relationship the same across all soil health values and all inorganic N contents? And then also, can a healthier soil actually just give you greater bang for your buck in terms of nitrogen fertilizer applications, right? Do you get a greater yield response in a healthier soil?